Next, we're going to take a look at how to find the zeros of a function. Remember, the zeros are another word for x-intercepts. So we already know how to find x-intercepts. We replace y with 0, or we find where the function f of x is equal to 0 and solve for x. Our first example is a quadratic function. So when we substitute 0 for f of x, we want to factor our quadratic expression. This one is a t-chart, what multiplies to -6 and adds to -1. If it helps you to actually organize your work in the t-chart, feel free to do that. The two numbers that work on this one are a -3 and a +2. After that, it's our zero product property. We set each piece equal to 0 because the only way to get 0 for an answer when you multiply is if you are multiplying by 0. So one of our binomial terms has to be equal to 0. Adding 3 to both sides, we got 1 0 of 3. Our other 0 is -2. So if we were to write these as ordered pairs as the x-intercepts of the graph, we started by substituting 0 for y, and we solved and got either -2 or 3 for x. Same process, substitute 0 for f of x, and then solve for x. Solving, we'll add 1 to both sides. To cancel the square root, we will square both sides and divide both sides by 2. So the 0 of this function is 1/2. Again, expressing that as an ordered pair, we got 1/2 for x when we substituted 0 for y. When you have a rational expression, you've got variables in the numerator and the denominator. What will make the entire equation 0 is if you have 0 in the numerator. So what you need to do is just set the numerator equal to 0. And when you're done, you will double check your domain restrictions in the denominator to see if you got something that you can't substitute in because you'd be dividing by 0. So we'll start by setting up our t-chart again. What multiplies to +14 and adds to -9, we'd get a -2 and a -7. Setting each binomial equal to 0 for our zero product property. Adding 2 to both sides on our first equation, we get a 0 of 2. Our second equation, adding 7 to both sides, we get our second 0 of 7. So far we think 2 and 7 will work. When we double check our original equation, 0 is what would make the denominator equal to 0. So both of these roots will work. So we'll set up our ordered pairs of 2 0 and 7 0. And here are your two U-try questions.